Welcome to INTELLO videos. This video provides a general introduction to the new INTELLO 1.7 software. The INTELLO introduction is divided into 5 separate videos. For best understanding, these videos should be viewed in order. The first part will introduce the home screen, the manual control, routine workflow, and the main parameters. Welcome to INTELLO 1.7. After installation, you will see this screen. In this screen, you can create a new profile. You can select or create one by clicking on this link here. And then you can fill in the name of your new profile. For example, student A. Create. And then select this profile. It will immediately start the INTELLO 1.7 software. And on the left side, you will see the procedures. We have now an Autolab library filled with application procedures, general procedures, and testing, and the data. At the moment, there's no measurement in the data folder because we have created a new profile and we start from zero with a new profile. If we go back to home, you'll see on the bottom the work systems. At the moment, there are no work systems available, so we have to select that with the plus button. In the plus button here, we can add a work system. There's one Vionic available, Vionic Office. And if you don't see a Vionic in your network, then you click here if your instrument is not detected. Then you write down the IP address of Vionic in your network. But we have this Vionic Office available, and then we add it to our work system ribbon in here. We can select it, and then we can claim it with this button here. Claim and connect to the work system. We come to the manual control of the Vionic. And this is a dual-purpose screen. It monitors and displays an actual state of the work system, and it lets us do simple manual actions, on top of displaying the same information as on the dynamic interface, so the display of the Vionic. Some simple actions can be done from here. For example, apply a potential and put the cell on. For example, we can put 1 volt, and at the moment the cell is off. You see that by the black rim around this cell button. And but we switch the cell on and press apply, the cell button becomes white, and we're applying 1 volt to, at the moment, a test cell. And we'll see what the resistance is, the current, and the power. We also see that the measured in the 1 milliamp current range. And if we change this into 3 volts and press apply, then the current range becomes 10 milliamp. This is a new feature in INTELLO 1.7. So this is the manual control. We can set it back to 0 volt, apply, and switch the cell off like this. And then the cell is switched off. In the upper right corner, you will see a pencil. And in the pencil, you can set up the work system. For example, if you want to change the name of the Vionic in your software, you can change it here. You can switch to floating mode if needed. And there are several ways of floating. Working electrode grounded, counter electrode grounded, or the complete cell body grounded. So that you can select different setups for different grounding states. Also, you can switch between high accuracy or high voltage mode, and also you can change the main frequencies, which depends on the main frequency in your country. If you work with light sensitive samples, then you can switch the light of the front display of the dynamic interface of Vionic. But that's the setup of the work system. We don't do anything with this. These are the default settings. Another nice feature is to pop out this manual control, so you can watch this manual control during measurement of an experiment. All right, that's one thing. So we go back to our home screen. We have a Vionic Office available for measurement, and so we can select from one of these procedures a procedure. Let's go to the procedures. In here you will find application procedures, like for example battery procedures, specifically designed for battery research. So you have a constant current, constant voltage, charge, discharge procedure, differential capacity analysis procedures, GITT, PITT. So we have designed ready-to-go procedures, which is for the battery field. But we also have for corrosion, for example, ASTM methods, linear polarization, Teflon analysis. We have photovoltaic, semiconductors, chronomethods. The general procedures are the general chronoamperometry or potentiometry type of electrochemical techniques. Then we have the CV, cyclic voltammetry, CV staircase, CV linear scan, potentiostatic or galvanostatic, different scan rates, linear sweep voltammetry, also electrochemical impedance spectroscopy, galvanostatic, potentiostatic, at open circuit potential or at different states of charge. Then we also have hydrodynamic electrochemistry, that's in combination with the rotating disc or rotating ring disc electrode, and pulse voltammetry techniques like square wave voltammetry and differential pulse voltammetry. In the testing folder, you will find some procedures to test the functionality of the Vionic. If it passes all these tests, then you make sure that the hardware is working for Vionic. So these are the Autolab library, and in the Autolab library we also have personal library where your own procedures are stored. But if you want to share your personal procedure with another user of this computer and this Vionic, you can share your procedure with it in a shared library. For example, if your professor put a procedure in there, then you can take that procedure and start an experiment. All right. Let's take a procedure from the Autolab library. We go to Autolab and we do, let's see, cyclic voltammetry, staircase potentiostatic. This one here. It's a very simple standard CV with a stabilization time of 5 seconds. Start at 0 volt, go to 1 volt, minus 1 volt, and back to 0 volt with a certain scan rate. All the details are within here, but if you don't need to go into deep for each experiment, you just change the main parameters on the left side of the procedure. For example, stabilization time we set to 1 to speed up the measurement, and also we can speed up the scan rate. The cell cables are connected to a test cell, and I would like to show you that you can follow the potential and the current in real time with the experiment. The procedure is automatically loaded in the Vionic, so it's available underneath the Vionic office, and then we can press start. You see the data is building up. Also you see that the resistance stay constant because it's a linear response of the applied potential with versus the current. And you'll see in real time the database is filled with the data measured. We can export, of course, to an ASCII file or to an Excel file if needed. So this is the CV staircase measurement. And if we go to another procedure, like for example, let's take EIS, electrochemical impedance spectroscopy. You'll see that it becomes available directly underneath Vionic. And in here, we can see as well what each for the main parameters and the main main screen main features are needed for this measurement. For example, first frequency, last frequency, and the amplitude. Those are the three main features which you have to, or parameters which you have to adjust to do this measurement. A nice new thing which we have implemented is automatic naming. So we go to, let's go to procedures. And in the procedures, you'll find also the end state of the instrument. So what does the instrument need to do at the end of the measurement? Switch the cell off, for example. But the nice thing is that we can also add metadata to the name, like work system, procedure name, cell properties, main parameters. So you can make a unique name based on the metadata. For example, cell ID. You can also add a name in front of it. Let's say student A, and gives you a procedure name, which is ES potentiostatic, and the cell ID. You can also enter additional things like normalize for surface area or mass, switch the cell off during a pause command, show invalid points. You can change the unit scaling, and that's all done in the procedure command. In the apply settings command, you can switch between potentiostatic and galvanostatic. You can set the cell on or off. You can set a potential. So there's no separate set cell and apply settings command needed anymore inside of the procedure. Everything is including in the apply settings command. When you press more, you will find the control loop, the bandwidth, how fast or how stable you want to measure. You can also do IR drop compensation, and you can select the current range. By default, the current range is set to automatic. So that's it. That's for the apply settings. And in the measurement command itself, you define, okay, these are the main parameters, but you can also say how the distribution you want to do. Do you want it logarithmic? Do you want linear distribution, or do you want custom? If you select custom, you can add and delete manually the frequencies and amplitude to the list. But by default, it's standard to logarithmic with 10 points per decade. Also, the signals can be selected. So here you can also measure the impedance on the counter electrode with the S2 impedance data. So these are the standard EIS, and we only have to switch on the cell ID and give it a name, let's say batch number 2. Oh. If everything is set, then you can start the measurement like this, and you can follow in real time the fill up of the data. So the data is appearing in real time, and you also see that happening in the plots in the plot ribbon. This is also a new feature in INTELLO 1.7. And you see the data is stored as student A, ES potentiostatic batch number 2. The measurement is finished, and here we have the data. Thank you for watching INTELLO videos. If you found this INTELLO video helpful, please like and share with your colleagues. Please subscribe to this Metrohm Autolab YouTube channel so you're notified when new videos are available.